हेलो स्टूडेंट्स, सो टुडे आज हम लोग बात करने वाले मैग्नेटिक फील्ड एंड मैग्नेटिक फोर्सेस. व्हाट आर मैग्नेटिक फील्ड्स, हाउ दे आर जनरेटेड एंड व्हाट हैपेंस व्हेन मैग्नेटिक फील्ड कम्स इनटू एग्जिस्टेंस. सो स्टार्ट करते पहले हम लोग करंट, हमने कुछ बेसिक कॉन्सेप्ट्स डिस्कस किए एंड करंट वाले चैप्टर में हमने मैग्नेटिज्म का कोई भी डिस्कशन नहीं किया था. ठीक है. एंड गाइज, जो मैग्नेटिज्म एंड करंट, ठीक है, ये बहुत सालों पहले माना जाता था दैट करंट एंड मैग्नेटिज्म बोथ आर वेरी मीन्स सेपरेट ब्रांच ऑफ फिजिक्स. ओके, बट मीन्स आफ्टर द डिस्कवरी मेड बाय Oersted, that was Oersted experiment, and it was in about 1820. Oersted experiment was there, and it showed that electricity and magnetism both are linked. Means they are not separate. They are not separate branch of physics. They both are related to each other. Okay. So guys, this is very interesting chapter, and according to your JEE means advanced perspective, other state level exams also, so you must have full concept of this chapter. It's very interesting chapter, so let us start. First of all, I'm going to give you an example. Okay, and the example is you are having a current carrying wire, and the wire is like this. You are having a current carrying wire. Current is passing through this wire. The current is I. Okay, आपके पास ये current carrying wire है, having current I, and a charge is placed near to this current carrying wire. That is, the charge is plus Q charge. Okay, plus Q charge is placed near to this current carrying wire, and what do you observe? हम लोग यहाँ क्या देखेंगे कि इस वायर में जब करंट कैरिंग वायर में जब करंट आई जा रहे and the charge is placed near to it, there is no any activity around this charge. We do not observe any activity here. But if we provide some velocity, to this charge, what do we observe? We observe that the charge experiences a force. And what is the reason of that force? Why this charge is experiencing the force if it is in motion, and it do not experience any force if it is at rest? Yes, there must be some relation between current and the motion of the charge. So let us find that what is the relation between the motion of this charge and the current that is in the wire I. Actually, what happens, guys, what happens here is, when the charge is at rest, it has only electric field around itself. What is electric field? Electric field is that region around any charged particle in which if any other charge comes, then that charge gives some force, that is force of attraction, force of repulsion, whatever may be the condition is. Means अगर कोई चार्ज रेस्ट पे रहेगा तो उसके अराउंड एक स्पेस बनता है, एक जगह होता है, और उस जगह में अगर कोई दूसरा चार्ज पार्टिकल आएगा तो उस चार्ज पार्टिकल पे ये Q चार्ज फोर्स लगाएगा, ये Q चार्ज उसको अट्रैक्ट करेगा या फिर रिपल्शन होगा वहां पर. दैट इज द concept, basic concept of electric field. That the formula for electric field is kq by r square, and r is the distance of the charged particle from this charge, test charge. Now we don't want to describe electric field in detail here. We are very much interested in the discussion of magnetic field. So guys, we know that if a charge is at rest, then it produces only electric field around itself. But if the charge moves with constant velocity, means we are providing some velocity v to this charge, means if we provide a constant velocity v to this charge, constant velocity v to this charge, it starts creating magnetic field around itself. Means the moving charge creates magnetic field around itself, and we can conclude that a current or moving charge creates magnetic field in this space, in the surrounding. Means this charge is creating a magnetic field. This current carrying wire has also a magnetic field. What happens here? Both the current carrying wire and the charge are having magnetic field around themselves. So what will happen? How this charge will deflect? How this charge will experience a force? So the basic concept here is, this current carrying wire creates a magnetic field around itself. Sorry, like this, it creates a magnetic field around itself, and magnetic fields form circular loops that we will discuss later. Their direction also we will discuss later. And this Q charge, when in motion with constant velocity, it also creates magnetic field around itself. So if both are having magnetic field around themselves, then the magnetic field of both the current carrying wire and charge will interact with themselves, interact with each other and will apply a force, and that force is called magnetic force, and that magnetic force is responsible for the deflection of the charge Q. Okay, so current carrying wire or a moving charge creates a magnetic field in the surrounding space or the surrounding area. And second point is, guys, the magnetic field exerts a force on any other moving charge or current that is present in the field. So the current carrying wire is having magnetic field around itself, and when this charge moves, it also creates a magnetic field around itself, and when both the magnetic fields interact with each other, magnetic force comes into existence. Okay, so this is the basic concept of motion of charge. Motion of charge creates magnetic field around itself. If the charge is at rest, then it will have only electric field around itself, guys. And a current carrying wire also has magnetic field around itself. So guys, now we are going to discuss Oersted experiment, which was very important experiment and which related electricity and magnetism together. Before this experiment, electricity and magnetism were two separate branches of physics, but after this experiment with Hans Christian Oersted, he proved that no, they are not separate branches of physics. They both are related to each other, they both are linked to each other, and that is why we used to have electromagnetism. It's combination of electricity and magnetism. So let us discuss this experiment, what it is all about. And it was performed in 1820 by the famous scientist Hans Christian Oersted. Actually, he observed that if we are having a current carrying wire, and current I passes through this wire, and a magnetic compass, magnetic compass, what is a magnetic compass? And magnetic compass is having a needle, and the needle, deflection of the needle gives the direction of magnetic field. The north pole in the needle tends to align itself in the direction of north. Okay, so you must go and watch what is a magnetic compass if you have not seen it. Okay, so suppose here a current carrying wire is having current I, and a magnetic compass is placed here like this. It is magnetic compass, it shows the direction of magnetic field. North pole provides the direction of north. So what happens, guys, here is when the current I passes through the wire, then we observe a deflection in the needle of the magnetic compass. The needle of the magnetic compass deflects due to the flow of current, and when we change the direction of current in the wire, then the direction of deflection also changes. There must be a relation between magnetism and electricity. There must be a relation between magnetism and electricity if on changing the direction of current, the magnetic needle deflects in opposite direction, or the direction of deflection of the magnetic needle changes, then there must be a relation between electricity and magnetism, guys. So this was the starting point of the combination of electricity and magnetism together. And if we stop the flow of current in the wire, then we also see that the deflection also stop in the needle. So if the current flows, the magnetic needle deflects. If the direction of current changes, the direction of deflection changes. If the current stops flowing in the wire, then the deflection stops in the magnetic needle. Okay, so the magnetic compass is having a magnetic field around itself. Okay, and if the current carrying wire is also producing a magnetic field around itself, then both the magnetic field lines, both the magnetic field of the wire and the magnetic compass will interact with each other, and there will be a deflection as discussed in the previous concept that we have discussed now. So this was the Oersted experiment. It was very important experiment, guys, and you must know what is the Oersted experiment. So now we will define a term here, that is magnetic field vector, and it is represented by capital B. Magnetic field vector, and it is represented by capital B. Capital B stands for magnetic field vector. It is a vector quantity, and its direction is the direction of deflection in the magnetic compass. The direction, that is the deflection of a needle in the magnetic compass, that is the north pole of the magnetic compass. Magnetic field vector, it is a magnetic field vector, and it is represented by B. It is having an SI unit which is Tesla, named after the famous scientist Nikola Tesla. Means he was having a very important contribution in the field of magnetism. That is why we, in honor of his name, we have used the SI unit of magnetic field as Tesla. Tesla is the SI unit of magnetic field. Next we are going to discuss force on a moving charge in magnetic field. Force on a moving charge in magnetic field. Guys, we have discussed why any charge that is moving in a magnetic field experiences force. क्यों कोई चार्ज अगर मैग्नेटिक फील्ड में मूव करता है तो वो उस पर फोर्स लगता है. तो वो जो है वहाँ पर हमने डिस्कस कर लिया कि अगर कोई भी मूविंग चार्ज जो है वो मैग्नेटिक फील्ड में मूव कर रहा है, देन इट एक्सपीरियंसेस फोर्स. व्हाट इज द बेसिक रीजन बिहाइंड दिस? नाउ there was an experiment which gives you a formula for a moving charge, force on a moving charge inside the magnetic field. मतलब किसी भी मूविंग चार्ज पे फोर्स निकालना है. हमने देख लिया कि कोई भी मूविंग चार्ज होगा मैग्नेटिक फील्ड में तो उस पे फोर्स लगेगा. जैसे पहले वाले केस में करंट कैरिंग वायर था हमारे पास, तो करंट कैरिंग वायर जो था हमारे पास उसमें अगर हमने एक चार्ज को रखा था एंड द चार्ज वाज मूविंग विद वेलोसिटी v, देन इट वाज एक्सपीरियंसिंग अ फोर्स. तो करंट कैरिंग वायर का मैग्नेटिक फील्ड था और चार्ज के मूव करने से उसका अपना मैग्नेटिक फील्ड आया. दोनों मैग्नेटिक फील्ड आपस में इंटरेक्ट करे और वहाँ पर फोर्स लगा. तो जो फोर्स लग रहा है उस चार्ज पार्टिकल पे वो कितना होगा, वो अगर निकालना हो तो उसके लिए एक फार्मूला आएगा, एंड दैट इज F is equal to vector F is equal to Q V क्रॉस B. आपने वेक्टर चैप्टर में क्रॉस प्रोडक्ट पढ़ा होगा, तो उससे आता है F is equal to Q V क्रॉस B. Q V क्रॉस B, where F is the force on the charged particle. F is the force on the charged particle. Q is the value of charge that is moving in the magnetic field. V is the velocity with which it is moving, and V is the magnetic field vector. So these are the terms, that is F is force, Q is charge, V is velocity, B is magnetic field. And F is equal to Q V cross B. Let us discuss this formula in detail. It was experimentally derived that F is equal to Q V cross B. And what is the direction of cross product? How you calculate the direction of cross product? So मैं यहाँ पर थोड़ा सा बता देता हूँ कि अगर आपको क्रॉस प्रोडक्ट करना है A का एंड B का, इन दोनों वेक्टर्स के बीच के एंगल दिए हुए हैं थीटा. सो अगर आपको A क्रॉस B कैलकुलेट करना है तो आप कैसे निकालोगे? सो गाइज इसके लिए आप राइट हैंड रूल यूज़ करोगे. दैट इज़ आपको A के डायरेक्शन में हाथ ऐसे रखना है और A क्रॉस B कैलकुलेट करना है यहाँ पर. तो A क्रॉस B कैलकुलेट करने के लिए आपको A की तरफ ऐसे हाथ रखना है और B की तरफ कर्ल करना है फिंगर्स को. तो थंब का जो डायरेक्शन होगा इट विल गिव द डायरेक्शन ऑफ A क्रॉस B. वही अगर आपको B क्रॉस A निकालना होता है तो आप B की तरफ ऐसे हाथ रखते और A की तरफ कर्ल करते, तो इनवर्ड इज द डायरेक्शन ऑफ A क्रॉस B. सो A क्रॉस B का जो भी डायरेक्शन होगा वो राइट हैंड रूल से हम लोग निकाल लेंगे. A क्रॉस B निकालना है इस तरह से थंब आगे, अगर B क्रॉस A निकालना है तो इस तरह से थंब इनवर्ड. सो यहाँ पर एक साइन कन्वेंशन होगा कि अगर क्रॉस दिया हुआ है दैट मीन्स इसका क्रॉस का मतलब होगा इनवर्ड, मीन्स इनटू द प्लेन। ये डायरेक्शन डिनोट करेंगे हम लोग इनटू द प्लेन, एंड अगर कहीं पर डॉट दिया हुआ है तो इसे हम लोग यूज़ करेंगे आउटवर्ड, मीन्स आउट ऑफ द प्लेन। ये दो चीज़ हम लोग मैग्नेटिक फील्ड में बहुत ज़्यादा यूज़ करेंगे, क्रॉस एंड डॉट। सो गाइज यहाँ पर देखेंगे हम लोग F इज द क्रॉस प्रोडक्ट ऑफ V एंड B। F इज इक्वल टू Q V क्रॉस B, V क्रॉस B है यहाँ पर। तो F इज इक्वल टू V क्रॉस B, then what will be the direction of force? So direction of force can be calculated with this method, cross product of vectors, that is Q V cross B। तो V सपोज हमने इसको और फर्दर डिटेल में डिस्कस करते हैं। गाइस यहाँ पर एक मैग्नेटिक फील्ड दिया हुआ है इनवर्ड, मैग्नेटिक फील्ड इज इन द inward direction, that is cross represents the magnetic field in inward direction, and a charge Q and a charge positive Q starts moving or entering this magnetic field with velocity V। This magnetic field is uniform, इस रीजन में जो मैग्नेटिक फील्ड दिया हुआ है वो यूनिफॉर्म है, और इसमें एक चार्ज Q एंटर करना चालू करता है विद वेलोसिटी V। So what will happen here? यहाँ क्या होगा? तो V का डायरेक्शन किस तरफ दिया हुआ है? V का डायरेक्शन इधर जा रहा है, मैग्नेटिक फील्ड में इधर जा रहा है V। And what is the direction of magnetic field? So this is the direction of magnetic field, that is inward। ये इस तरह से inward is the direction of magnetic field। And we have to calculate the direction of force on this charged particle। So V की डायरेक्शन दी हुई इस तरह से, and magnetic field is inward direction अपने तरफ, ये इस तरह से दिखेगा। So V cross B, we have to calculate V cross B, because V cross B gives the direction of force on this charged particle if it is positive। सो V के डायरेक्शन में हाथ ऐसे रखेंगे हम लोग, V के डायरेक्शन में हाथ ऐसे रखेंगे हम लोग, और अपने फिंगर्स को कर्ल करेंगे टुवर्ड्स द डायरेक्शन ऑफ मैग्नेटिक फील्ड। सो थंब इज इन अपवर्ड डायरेक्शन, एंड दिस इज द डायरेक्शन ऑफ फोर्स ऑन दिस चार्ज्ड particle। This is the direction of force, and this is the direction of velocity, and inward is the direction of magnetic field। So when this charged particle enters this magnetic field, it changes its path and it starts deflecting in this way because of the magnetic force that is being applied on this charged particle by the existence of magnetic field here। So this charge will deflect in a direction like this, and it is very important concept, guys। Now there is a condition, if the direction of velocity vector and magnetic field is parallel, then what will happen? So what was our basic formula for this? That is F is equal to Q V cross B, means Q V B sin theta। A cross B is AB sin theta, that is why V cross B is VB sin theta, where theta is the angle between V and B। So if the charge moves in a direction perpendicular to the direction of magnetic field, then theta becomes 0 degree। Theta is 0 degree, so theta is 0 degree because both are parallel to each other, and the force becomes 0 because sine 0 is 0 So if a charged particle moves parallel to the magnetic field, it do not experience any force. But if the charged particle moves perpendicular to the magnetic field, means in this case velocity vector and magnetic field vector both are making an angle of 90 degree with each other, means in this case theta is equal to 90 degree, so force is qvb sine 90 and this is qvb. So this is the value of maximum force that can be applied on this charge due to this magnetic field. Means theta is 90, means sine 90 is maximum, that is why this is the maximum force and this is the zero force, because the magnetic field is parallel to the motion of the charged particle. And now guys, our next topic is if a charged particle is moving at an angle theta with the direction of magnetic field. For example, suppose this is the direction of magnetic field vector here. This is the direction of magnetic field here. Magnetic field is in the direction like this, magnetic field, and a charged particle starts moving in a direction of angle, it is making an angle theta. Velocity vector is making an angle theta with the direction of magnetic field. So this is the direction of magnetic field and this is the direction of velocity here. So this is the direction of magnetic field and this is the direction of velocity, and you have to calculate the direction of force. So V cross B, V, curl your finger towards B, sorry, V cross B. V is in this direction and magnetic field is in this direction, so you have to curl your fingers from V towards B and is inward. The force is in the direction of thumb, that is inward. So the force here is in inward direction. The force here is in inward direction. So V cross B, the force is in inward direction, means the force is perpendicular to velocity as well as magnetic field. Now यहाँ पर guys हम लोग थोड़ा और ध्यान देंगे that this velocity vector can be resolved in two components. This is theta, so it can have two components, that is V cos theta along this direction and V sin theta along this direction. So there are two components of the velocity vector here. This is the parallel component, means parallel to the magnetic field, and this is the perpendicular component, means perpendicular to the magnetic field. So the force, we want to calculate the force due to parallel component of velocity. So what is the formula for this? F is equal to Q V cross B. This will be equal to 0. The force due to the parallel component of velocity is 0 because the angle between the parallel component of velocity and magnetic field is 0 degree. Both are in parallel direction. And the force due to the perpendicular component F perpendicular is equal to Q V perpendicular cross B, which is F V sin theta into B. Perpendicular component cross B and both have an angle of, इन दोनों के बीच की जो एंगल है वो 90 डिग्री है, दैट इज बाई क्यू वी बी लिखेंगे हम लोग और साइन 90 लिखेंगे. मीन्स दी if velocity vector makes an angle theta which is not 90 degree, which is not 0 degree, then it is having two components. One component is along the direction of magnetic field and the other component is perpendicular to the direction of magnetic field. The force is only applied, or the force only comes into existence due to the perpendicular component of velocity. Parallel component of velocity do not have any role in the force, because the parallel component makes an angle of 0 degree with the magnetic field, so it will not give any contribution in the force, value of force. ये फोर्स में कोई भी कंट्रीब्यूशन नहीं देगा. इट विल नॉट चेंज द डायरेक्शन ऑफ द चार्ज पार्टिकल बिकॉज इट इज नॉट गिविंग एनी कंट्रीब्यूशन इन द वैल्यू ऑफ फोर्स. ये फोर्स के वैल्यू में कोई भी कंट्रीब्यूशन नहीं दे रहा है, मीन्स दिस इज नॉट responsible for changing the direction of the charge particle. The direction of charge particle only changes due to the perpendicular component of velocity. And this is the concept for the velocity making an angle theta with the magnetic.